webinar, more detail on our level being 9 mastery, more detail on our level being 9 mastery program. Wow! Mastery program. Level being 9 mastery. Welcome to You Learn Naturally Radio, Black Open University. Richard Tozer, thank you for joining us during our British Science Week program. We have a very, very interesting discussion ahead of us. You have been doing a DIY beehive monitoring project. Please introduce yourself and let's explore what you've been doing in the world of STEM, of engineering and science and technology around beekeeping. Richard, welcome to You Learn Naturally Radio.
Hello. Yes, thank you for inviting me to speak. My name is Richard Tozer. I'm a software developer, and I've built a DIY beehive monitoring system. Nothing game-changing. It's just a simple system to collect some data from our beehive, largely to satisfy my own curiosity.
Okay, cool. And when you say our beehive, are you the main beekeeper? You have, what's your beekeeping setup?
Here we go. This is, my wife is actually the beekeeper. She's a vet, a microbiologist, and an eco-warrior. She believes insects are going to play an important role in sustainable food production and waste management in the future, and has a few projects on the go. Her grandfather kept bees for thousands of hectares of citrus valley in South Africa, so she was no stranger to bees growing up, and I think always wanted to keep bees herself. So getting on hands-on with some beehives was a natural place to start.
It looks like a beautiful place. Back home in South Africa, that's a large space of land. Good stuff. And I'm very interested in what you just mentioned regarding the food and the waste management. Perhaps we can talk about that differently.
Yes, we can do. So yes, we want to talk about why we want to monitor the bees. So here's some very obvious reasons you might want to monitor bees in a dense urban environment. Keeping bees in a small garden in London is certainly very different to keeping bees on a huge citrus farm. You don't want your hive swarming and taking up residence in a neighbor's chimney. It can be very expensive to remove them, and if your neighbors complain, they can put a stop to your beekeeping. But beekeepers primarily monitor a hive to track the health of the colony. In fact, I believe it's a requirement to inspect for some diseases. So devastating, you're required to report them immediately and burn the hive and everything in it to prevent the disease spreading. But beekeepers are looking for other things as well when they inspect the hive. They're also looking for pests like wax moths and varroa mites, and even slugs and mice can get into a hive. And also how much space the colony has to expand, how many stores they have, if there's eggs and brood, the health of the queen, whether the hive is trying to produce a new queen, which is a clear indication the hive is preparing to swarm. And they do this by opening up the hive and inspecting the frames. It's a manual process. You do it every week in the warmer months, and it can take some time. So I had been considering how we might automate the process. But these things that the beekeepers are looking at, they don't lend themselves to automated monitoring the possibly computer vision, machine learning. Computers are getting very good at analyzing pictures and recognizing features and objects, but in order to do that, you would still have to open up the Hive and pull out all the frames to get the images to analyze, which would actually take you longer than just inspecting the Hive. So I had been thinking that there's certainly other things that you would want to measure. You've probably heard the phrase, you can't manage what you can't measure. And it applies here too. You can't spot correlations in data that you're simply not aware of. So yeah, I'd been thinking it would be nice to monitor the Hive, but I wasn't quite sure how to go about it. I had investigated some commercial systems and was put off mainly by the price. They're very expensive, hundreds of pounds for the equipment, and then often they're designed to be deployed to remote locations, so they have GSM mobile phone signals, and you have to pay for ongoing contracts for those as well. So yeah, I investigated the pros and cons of commercial options and doing it myself, and decided it would probably be the way to go to do it myself. It would be cheaper and rewarding and more fun to do it that way.
Well, I'm very glad that you did do that, Richard. This is where we intersect in terms of our interests. So perhaps this is a good time for me just to expand a bit on why I'm so pleased to have you speak about your project. But before I do, because obviously for you to be able to think through the pros and cons of doing it commercially or doing it yourself, obviously you have to have the capacity to do it yourself. So can you just tell us a little bit about how you've come to get the skills to do this?
Well, I didn't have many of the skills at all when I started. I've been learning as I go. I am a software developer, which was very helpful for processing the data once it was collected and making it useful. But yeah, most of it I learned as I went, and it wasn't that difficult. But yeah, it was a lot to take in.
Well, this is the whole thing now where we intersect, because we're focusing in on the science of beekeeping for British Science Week 2021. And inside of that, we're doing that because we are a learner cooperative focused on steamed up learning. So that's STEM plus the arts. We have a cadre, a body of cadets who are in a program called Level Being 9. And that essentially is about approaching the science, technology, engineering, and math in creative ways, in hands-on project-based learning type ways, and extracting from the project or the creativity or the productivity all of the key points that would relate to for example, the GCSE curricula around math and science in particular. So when we had started this program, the business of monitoring came up more from the angle of engaging the STEM. And as you said, monitoring is important for management, but we were approaching the monitoring from a point of information for learning, for studying the real nature of the bees in the context of the beekeeping and the beehive. So I'm very glad you've done that, and yeah, well done.
So yes, having decided I've certainly been leaning towards doing it myself, I didn't really know where to begin. So on a rare night out, back when it was possible to get a babysitter and actually have a night out, we attended a talk by Dr. Gordon Hunter of Kingston University on the use of mathematical methods to monitor the well-being of honeybees. By the way, this counts as a romantic date if your spouse is a scientist, and possibly applies to beekeepers as well. And he had used Raspberry Pis to collect the data that he was analyzing, and his setup looked really simple and easy to do. It really encouraged me to have a go at building my own, especially since I actually had used a Raspberry Pi before. I certainly hadn't built any circuits, but I had installed software on them and used them. his talk also prompted me to include recording audio from inside the Beehive, which I hadn't considered at all. I hadn't thought that it would be useful, but he had done some analysis of the spectral envelope and shown that it could predict things like swarms.
That's a very interesting thing, predicting the swarm. Do you have any more? Did you share any more insight? Perhaps you can just tell us a little bit about that. How does that go?
I'm not sure what the signal is, but the bees are preparing for some time before they swarm. It's not a lot. It doesn't give you a lot of warning. I think it was something like 20 minutes. I actually also, sometime after I'd built the system, discovered some AI audio analysis, which also showed that you could predict swarm activity from the audio. And in fact, I've set that up and it's running on my system now. It's not quite as accurate as I would have liked, but it's certainly accurate enough to be interesting. We can have a look at that a bit later when we delve into the data.
Okay.
So yeah, having decided I was going to build it myself, I needed to decide what to actually measure. I was aware that temperature and humidity inside the hive would be useful, as well as the current weather, the external temperature and the humidity, whether it's raining, and that the weight of the hive would be good to have. In fact, the hive weight is always the first feature that beekeepers express an interest in when I mention the system. I also wanted video of the entrance. When you walk past a beehive and look at the entrance, you can actually tell a lot about what's going on just by seeing how much traffic there is in and out and whether there's pollen coming in. Pollen is used to feed the brood, so it's always a good sign. You can also see if the colony is being harassed by wasps or bumblebees. And then Dr. Hunter's talk added audio to the list, as I mentioned, and also light levels. He was monitoring how bright it was. And then I looked at the existing commercial systems to see what they were offering. And I think the only other thing was movement sensors, usually used to tell you if the hive had been bumped or knocked over. But since I was measuring the weight, that wasn't really necessary. I also track various statistics about the pie itself, how much disk space is free and how much load it's under and the temperature of the CPU, things like that. And then for the sensors, I basically just Googled. I looked for things that were small enough for what I was looking for and cheap and common, and whether there were libraries and tutorials available for how to use them.
So just to be clear, so before this, you hadn't really gone this far into using Raspberry Pi?
No, I had built a web interface to a 3D printer using a Raspberry Pi, but I hadn't had to do any coding at all. You basically just plugged it in and installed existing software. So I had Raspberry Pi computers lying around, but I had never used them for more than as a simple computer.
I like this tech spec for your sensors. I'm recognizing some things. This is probably another good point before you delve into this data. The BME 280 temperature and humidity, this rings a bell to me because we have another project. As I mentioned, we're a learner cooperative focused on steamed up learning, and so we're very interested in getting just the right kinds of projects where we can extract all the learning from it. So we have another project which is around high altitude balloons, the launching of a high altitude balloon with a payload that contains several things in it, which are partly about monitoring. So I recognize that components in regard to us wanting to measure the temperature and humidity as the payload and the balloon go up to the stratosphere. So it's kind of cool. Tell us about this table.
The BME 280 actually also can measure barometric pressure, and from that it can work out altitude. So it's probably a very good sensor to have on a balloon.
Yeah, that's right.
So yes, this is what I ended up with. For the weight, I used 4 50-kilogram load cells and an HX711 chip. These things are ubiquitous. Every digital bathroom scale in the world based on this. The kitchen scales as well will have a different load cell, but the same hardware inside.
So just for because not everyone is up to speed on this, what is a load cell?
So a load cell is a strain gauge. It's actually quite a smart little piece of kit. It's based on a piezo crystal, the same thing that you use to light a gas stove. You push the button and it goes clunk and creates a spark. It has some interesting properties. If you bend it, its internal resistance changes. So if you stick one to a piece of metal and pass a voltage across it and then bend the metal, you can detect how much the metal is being bent by a change in the resistance or change in the voltage that you're reading.
Okay.
We use 4 of them in what's called a Wheatstone bridge configuration, which is, if you imagine a diamond where each straight edge is one of the load cells. If you apply a voltage across 2 opposite points, say the top and the bottom, and then you measure the voltage across the other 2 points, the left and right, then it averages out across all the sensors. You'll always get the same reading whether you've got all of the weight over one or evenly spread across the lot. So it ends up with a very easy way to measure how much strain you've got or how much weight you've got on the system, independent of where it is.
Okay,
and
that's cool.
It's incredibly accurate. It's within a few grams. You do have to calibrate the system. You're just getting a number out which represents your voltage that you're reading. As long as you're putting the same voltage in, you'll always get the same voltage out for the same amount of weight. And yeah, it's very accurate once you've calibrated it. You just put a known weight on it, make a note of the number that you're reading with no weight and the number that you're reading with the weight, and it's a linear relationship pretty much over the whole range that your load sensor is good for. So in this case, about 200 kilograms.
Yeah, that's very good. Okay,
and,
cool.
Yes, the BME 280 that you're familiar with for temperature and humidity. I'm actually recording the barometric pressure as well. I haven't found any use for this yet. It was there, so I'm keeping it. And then I use a little chip called a VEML7700 for the light levels. It has a huge range and is very sensitive, but you see from the minimum and maximum values that I've actually recorded, we're using a very small range. So 300 lux is about how bright it is in a supermarket. It doesn't get very bright at the entrance to the beehives. And then the external temperature and humidity, I found a free weather service called Open Weather Map. And they have a weather station about 200 meters from my house. So they're more than accurate enough for what I need. I had originally tried to measure those values myself, but I put the sensor inside the enclosure with the Raspberry Pi, and all I was reading was the temperature of the CPU.
Oh. Is it possible to put it somewhere else, to have the sensor maybe wired so it's further away?
Yes, I had another project on the go, which is still sitting in pieces on my desk, to actually build my own weather station separate to the beehives and to record all this information for myself. But it's kind of been on hold because I got all of the information that I need, probably better than I can do myself, that I can just grab for free off the internet.
Okay, cool. That's very cool. Good.
So yeah, having decided what I was using, here's my first attempt. it came out really well. It actually worked pretty much as intended on the first try. I was really chuffed with the outcome. It was not without its problems. The first and most obvious one, and the one that still plagues me, is that I built this sensor to sit in an existing ventilation slot that was cut in the side of our hives, and it wasn't insulated to the inside temperature, so it was exposed to the outside, so it was colder than the hive, so I was getting a lot of condensation on these little components. This one's the BME 280 and this one's the microphone, and it was skewing my humidity readings and destroying the microphones. In about 6 weeks the sound became completely garbled, and I wanted to replace these, but then discovered I'd hardwired everything and glued everything in place and soldered everything, so I couldn't just swap out the components. I'd also 3D printed the enclosure, which is not particularly waterproof, so I had to build this little rain hat for it. And choosing black filament to print the entire enclosure was a bad idea, because in direct sunlight it gets very warm, and it's a thermal plastic, so when it gets hot it starts to get soft and it sags, and your view of the entrance gets lower and lower.
Oh, interesting. What would you choose? What's the alternative?
I think my current thinking is that the whole unit shouldn't be mounted in front of the hive. The pie can probably sit underneath the hive, out of the weather, and just a small camera module can sit in the front. I think the 3D printing will probably be sufficient for that, or a little aluminium strut or something. Once you have a 3D printer, every problem becomes a 3D printing project. So it's possibly not the best way to go about it, but it does look neat.
Just out of interest, what model printer do you have?
I've got a Prusa i3 Mark III. It's one kind of the top end of the hobby models, not a professional model. It's actually been remarkably good. It works very well.
What kind of things have you printed differently from this?
All sorts of things. Anything breaks, brackets, anything plastic that's broken gets modeled and replaced. Bits of door handles that are broken, anything.
Okay, very interesting. Okay, cool, good.
Yeah, so I'd also used an out-of-the-box solution for the video called RPi webcam interface, which does exactly what it says. It provides a web interface to the camera. It's actually very neat. You can control all the settings of the camera, and you can schedule recordings, and you can set up time lapses. It even does motion detection. It was very neat. I used it to trigger time-lapse recordings of the entrance every time motion was detected. But there were some issues with that as well. The live feed was very low resolution and low frame rate, and it didn't include the audio. And I was recording locally to the SD card, which is not what they're designed for. They have limited rights. If you're writing over and over and over to them, you can wear them out. And I was uploading the video automatically at night to Google Photos, a free photo service. And the downside of that was you couldn't actually look at the footage until the next day. And the same with the sensors. I was just sticking them in a CSV file, comma separated values. It's just a plain text file with a list of values separated by commas, and then uploading them to Google spreadsheets at the end of the day. And it's great to have the data in a spreadsheet, but you can't see what's happening live. And the Google free charting and analysis tools were very slow and painful to use. So yeah, all little things. It worked pretty well for a first attempt, but it was enough to prompt me to start over on version 2. So yeah, here's my second attempt. I got rid of the sensor inside the enclosure because it wasn't giving me any useful data. I tried to make it all a bit more compact, and I tried to add connectors for the cables so that if I had problems with the sensors, I could just unplug them and plug new ones in. But this rat's nest of wiring here and trying to solder wires to pins was all just too fiddly, and this never actually made it into use. It was too fiddly and too fragile. I realized what I was trying to do here with this pin board was actually to recreate a circuit board with header pins. And so I decided what I actually need to do is to learn how to create a circuit board that does everything that I need. So I ditched attempt number 2 and moved straight on to Mark 3, which you can see looks much neater. It's much smaller. I discovered it's quite simple to design a simple circuit board like this, especially when there's no circuits involved. All this is a wiring aid. It's just connecting pins over here to pins over there. And you can order them from China for a couple of pounds. It's really simple.
So you designed them and maybe online, and then they ship over your design. Is that the idea?
Yes, I used a software called Eagle CAD, which I had a hobby license for with my 3D printing. That also does 3D design. And so I designed it, and then you just produce a fabrication file which you send off, and they build it and post it back.
So just to be clear, so the Eagle CAD, is that for designing? Is it also for designing boards, or is it that you made a 3D model of a board and then sent it to them?
Eagle CAD is specifically for designing circuits and circuit boards.
Okay.
I've actually had to move on because the commercial license is very expensive. So if I ever want to sell or even make available these circuit boards, then I can't do it under my current license. So yeah, it's very nice software, but I've had to move on from it.
Okay, so well, I'm glad to hear that you've moved on. Obviously, you've moved on to something open source.
Yes, so I've tried a couple of options. There's one called KiCad or KiCad, I'm not sure how you pronounce it, which does much the same thing as Eagle. And then there's free open source online, or not open source, but free online services that you can use as well, often provided by the Chinese companies that do the printing. They want it to be really easy for you to put something together for them to ship to you.
Don't they need a volume, or they could just do like a small number of boards?
Yeah, you can do quite small amounts. I think I only did 5 on my run of these. They do put them all together, so they'll go through with a load of other components as well. They're not just monopolizing an entire factory to build one little board.
Okay. Well, that's interesting.
It's been very useful. So yeah, having built the system, which was actually the easy part.
Sorry, before you go on to this, can you go back one slide again?
Sure.
So, can you just explain the blue mounting parts? Just explain that slide to the right.
Yes. So
that image.
These are the internal sensors that go in the ventilation slots. They use these DuPont connectors, or they're just header pins, and they sit on this 3D printed bracket, and that fits inside these little enclosures, which have a grid on the front to stop bees from climbing into them.
Those are 3D printed as well?
They're all 3D printed as well, yes.
Wow.
And they just go into the side of the hive. You can actually see them on the first slide if I just jump back. So there they are, sitting sitting in the side of the hive.
Mm.
You see they're a bit exposed to the weather on the outside.
How have they gone through the winter?
I've actually further insulated them. I think I've got a picture a bit further on where you can see. Because they were tracking a little too close to the outside temperature.
Webinar, more detail mastery. On our level being webinar, 9 mastery program. Level level 9 mastery program. Wow! Mastery program. Level being 9 mastery.
Yeah, so with the version 3, I switched from the dumping the data into a text file and uploading it at night, and moved to a more Internet of Things paradigm where I broadcast the data in real time over the Wi-Fi network at home, and I put it into a time series optimized database called InfluxDB. Which is also free for personal use, and then make the data available to view as charts in a program called Grafana, also free for personal use. The dashboard is not what we use every day for a quick look at the current data, but it's been very useful for analyzing historical data. In fact, we can have a look at some live data, probably.
Before you go to the live data, before you do that, so
Yeah.
did you manage to resolve the business of doing end of day sends? You were sending the data in batch at the end of the day, and then being able to review it the next day, essentially. So did you move from that position to live analysis?
Yes. So I used an Internet of Things lightweight messaging system called MQTT. And basically, I just broadcast a little message every time I read the sensors, and I collect that up at a central location on a computer in the house, and I put it straight into a database in real time, so we can look at up to the minute data.
So your hive essentially could be anywhere.
My system needs Wi-Fi to communicate, so it's useful if you have Wi-Fi around your own house, but it wouldn't work if you had hives off in a field very far from anywhere.
Okay.
That's where a commercial system with GSM or LoRa, the long-range networking solutions, would be more useful. Although I am looking into options along those lines as well. Not for any current personal need, but just because it's interesting.
Okay, well, I'm very glad you have interest for that. You're intersecting again with our high altitude balloon project, because we have GSM. We entered the realm of radio transmitter components and the configuration of them, and also the GSM monitoring as well. Our balloon, the idea is to use those two systems to track the position of the balloon. It's interesting because at a certain height, the GSM doesn't work. The GPS systems don't work for tracking from the ground with that technology on it. So you need the radio transmitter to keep consolidated track of the balloon. And obviously, when it goes up past a certain height, if you lose track of it, you're not likely to be able to see where it comes back down again. Mm. But
The,
anyway,
the GSM is only going to work where there's cell tower range, and LoRa also only has about a 10-kilometer radius, ideally, and you're probably getting higher than that. So yeah, you definitely need radio of some type.
Okay, cool. So the dashboard, you were just about to take us into a live view of the dashboard. Is the live view? Okay, I see. This is the live view now?
Yeah, we're looking at live data now. This is currently the last 2 years. So you can see I started collecting data just over a year ago. We've only been keeping bees for a year now, just over. And yeah, this wide view is quite nice to see some general trends. You can see the average temperature rising and falling. We've got temperature here and humidity. In fact, you can see the problem I'm having with the humidity sensors maxing out at 100 quite often when they really should be tracking closer to the average here.
Right. So what's the cause of that then?
It's a condensation. It's because they're sitting in a non-insulated part of the sidewall and are exposed to colder temperatures.
Right.
There is a lot of humidity in the hive, especially when the bees are producing honey. They actively dehydrate the nectar to create honey, so there is a lot of moisture coming off. And then at night it condenses, sometimes on the sides and always on my equipment.
You've made me wonder if there's another component that maybe could track some sort of chemical sensitivity in terms of what is in the nature of the humidity, what's in that basically. Did you come across any sensors like that?
There's certainly sensors that can detect various alcohol compounds, even in the air. In fact, I think there's a BME 680 is related to the BME 280, but adds an air quality measure which can detect various, I think, alcohol in the air. I'm not sure. I haven't investigated too much, but it's actually one I should have a look at to see if anything interesting comes up.
Air quality, fantastic.
Yeah. In fact, I think Dr. Hunter had been looking at air quality. He'd found cyclic dips in the air quality, which I think he had attributed to rush hour traffic. So
fascinating.
Yeah, we've got the audio AI analysis that I got working eventually. And here you can see the history of our hives. We started with 1, and then we split it to 2, and then we split again to 3 hives. And you can see just how rapidly they bring in nectar during the summer. They go from 20 to 60 kilograms. And you can see where we harvested. In fact, it might be worth having a closer look at a good nectar flow. So here you can see they're bringing in a kilogram a day, and sometimes double that. And it tracks quite closely with the temperature, the productivity. You see this day here where they brought almost nothing in corresponds to a day of heavy rain.
Right.
So yeah, it's nice just to be able to see that the data is there, and it all
makes sense.
It makes sense, yes.
Well, as I think I was saying to you before, when we were preparing for this, we in our program we have a way to simplify the approach to information like this. So we focus in on the number, measure, and ratio, and we define for the young people, for the youngest children, what is number, what is measure, and what is ratio. So this kind of information, I think we've had our conversation has really, we've journeyed very nicely into this, because if someone were presented with simply this, you'd have to be technical to really be comfortable with it and know what you can glean from that. But when you're clear on what number, measure, and ratio are, then this kind of information is really fantastic. number being a tool of perception. So, yeah, well done. It's great.
Yeah, it's proved very useful. This, you can see the weekly inspections opening up the hive and having a look inside.
Mm.
If we have a look at some more recent data, we can have a closer look at here's a hive inspection. So here we can see, taking the boxes off the top and inspecting all the individual frames, it takes about 20 minutes for a quick inspection.
Mm.
And, you can see that it doesn't affect the internal temperature too much, or the humidity, but you can see the bees aren't too happy with it. They get a bit angry while the process is happening.
What's the monitor up there that you're saying indicates their temperament?
So this is the audio analysis, the AI that's listening to the signal that's coming from the microphones.
Right.
It is saying odd things like missing queen and collapsed. I found it's a good indication of their temperament. Yes, active is, they're definitely out collecting pollen and nectar when it says active, and they're definitely dormant. This will be at night. They're not doing very much when it says collapsed, and they're definitely agitated when it says swarm. They're not actually swarming.
I see.
It has an interesting function that's called pre-swarm, which lines up with what I was saying earlier. The only seems to occur about 20 minutes before they actually leave the hive, and would be a very good one if you to get an alert. In fact, I've set up alerts if we ever see a pre-swarm reading from this system, it sends a message.
So it will ping you if it's going to get to that point. If it gets to that point,
yeah.
Very
you
interesting.
can actually use this Grafana. It's got a built-in alerting. I think you could see some on the big view where we open. Every one of these lines here is some event. I've got big drops in weight. Send me an alert in case the hive's been knocked over. But then, of course, they also alert when you take frames off.
Very interesting. That AI sensor, and I do keep tabs on AI development. We have a related project called Ecosystem Art, which is all about education and the distributed ledger technology, or blockchain and DAG and Web3 technology, crypto technology. So I'm very present to the way that AI is developed through training data and things like this. I think it would be very interesting to speak to the people who made that AI software and learn a bit more about how they did the training data for this.
It's a group called Hive Eyes. I actually discovered them quite long after I'd built my system. It probably would have been quite helpful to find them earlier. They're building open source hardware and software for beehive monitoring. So exactly what I was doing. It actually might have been detrimental. I might have ended up just using their system instead of learning all the things I've learned. But they made this freely available to use, and they did explain how that was trained. It was trained using videos that they found on YouTube of specific events. So they would collect videos of swarms and then train it to detect swarms using the audio from those videos.
I would have thought, given what I've my little insights on this AI training process, I would have thought they'd want to connect to everyone using their software to get live training data.
Yes, I don't think there's a lot of commercial systems that provide a live audio feed, especially the ones that are designed to be deployed out in the field. They often run on batteries, and recording audio full-time is expensive, and broadcasting it would be even more expensive. So there's probably not that many people who are actually recording audio from their hives, unless they've got some kind of DIY setup like I've been building.
Even let's say pseudo live, like if you were telling them, if you were sending them your reports and actually telling them what really took place, during the sound variations. That's a thing.
Yes,
That's a thing.
definitely. That's one of the reasons we're collecting all of this information. It's you can't train a predictive AI without loads of data and actually flagging the events that you want it to be able to learn about.
Okay, cool. Very, very cool.
Yeah. So one last strange anomaly we have here: every day for about 30 minutes to an hour, the weight of hive number 2 jumps up by around 3.5 kilograms, and it does it quite consistently every day. You can see here for about 45 minutes the weight jumped up and then jumped back down again. And turns out my cat rather likes sitting on hive number 2.
Oh, wow.
There she is, my favorite spot. I don't know whether it gets a bit of sunlight at that time of day, but yeah, every day she sits up there for a good half an hour. And you can see from the audio analysis that the bees don't seem to be worried about it. They don't get agitated, despite her jumping down off the top of the shed and landing quite heavily on it.
That is interesting. I think that from my little insight with cats, obviously they're really in tune with vibrations, because I expected that the hive is vibrating.
Yes,
and the cat is.
She likes this.
Yeah, the cat's enjoying that. Fantastic.
You can see the insulation. I tried adding these little polystyrene balls that you get. They're used for swimming lane dividers and things like that. I put that over to try and insulate the sensors a bit better. So this is the system that we use for day-to-day monitoring. These are screen grabs from my phone. It's another free and open source piece of software called OpenHab, which is actually for managing home automation. It's used for consolidating the management of various internet-enabled home appliances like Hue lights and security cameras and smart vacuum cleaners and garden irrigation. Anything you can automate, you can find a way to get it working through here. It's really easy to build custom little miniature dashboards, and they render very well on a phone. So I've added all of the bee data here. I've got 3 levels. This is the overview. I had very high hopes for the audio AI, so it's right up front on the first page, and then a list of the hives with their current weight. And then you can drill down on the hives and you get the current values from the sensors. And
so before you go to that, regarding the audio, is there another audio sensor other than the one related to the audio AI?
No, it's just a standard pair of stereo microphones. They're INMP441, just the cheapest ones I could find online. They're not particularly good quality, but good enough for what we're doing. I record quite high fidelity, a 44 kilohertz, like CD, almost CD quality. The AI is analyzing only 8 kilohertz, so it actually gets drastically down sampled before fed to the AI. But yeah, I feed that out with the video stream now. It was actually, I think, the hardest part of this entire project was switching from recording to the SD card to actually streaming the audio and video. It took me about 3 weeks to get it working. There's loads of examples out there, and they all don't quite do what you want. I actually ended up having to really delve into it and understand far more than I ever wanted to know about video streaming to get that working. But yeah, it's been very, very helpful, because now we can run the AI in real time as opposed to applying it to a recording from hours ago. And you can get, when you open up on your phone, you get the real-time video and audio. You can hear what's happening. You can see what's happening. A little overlay, so you can actually see the current sensor values directly on the video.
I mean, this is if I can just add another context again, referring to our project, our high altitude balloon project, because this consideration came up in that. Because obviously you have sensors in a payload, it's going to make a journey, and you have a choice for having that data stored on an SD card, and then you collect the data when you collect the payload when it lands somewhere, or you try and have it stream the data while it's doing what it's doing on the journey. And obviously to get the streaming, then you need more equipment and heavier weight and other considerations like this. So I'm just relating those considerations. We landed quite quickly on just having it in the SD card, but I definitely would like some elements to be streamed, because if, for example, you were unable to retrieve the SD card, it means you've lost all the data.
Yes,
Yeah.
Streaming high definition video actually requires quite a lot of bandwidth. It might be difficult to do over radio, but you could certainly send snapshot pictures and sensor information back as it's going here.
I don't think I would stream the video, although that's what people would want. I would stream the other data. I'm interested in it. If we lost the video and we captured the other things that are being monitored as technical information, I'd be okay with that as a compromise.
Yeah. Especially readings are tiny.
That's right.
You could send in real time. Yeah.
That's right. They're much easier to send than the video. Okay, fantastic. Yes, you were saying.
Yeah. So yeah, then you can drill down further on the weight and get some charts. These are provided to OpenHab by Grafana, the same graphing program we were using before, and there's some deltas as well. You can compare the weight now to the same time the day before and also the week before, so you can see whether you're trending up or down. You can see this one is my second hive, which is a bit weaker and is trending down quite a bit at the moment. And then you can also get up to the minute graphs for the last hour, day, or week. So really easy to have a quick look at what's going on.
Okay, cool.
So yeah, some pictures of some other issues encountered. We had a few days where the bees decided to hang out on the pie. It's completely obscuring the camera. The pie is quite warm, quite a bit warmer than ambient, so maybe they like the temperature, or I believe they're quite sensitive to electromagnetic waves, so maybe they just didn't like the Wi-Fi. But they just hung out here for a few days. They weren't. I don't think they were trying to swarm or anything. They just came and sat out here.
And, what sort of time of year was that?
I can't remember. It was, I think, late, maybe autumn sometime. It certainly wasn't freezing like this. They wouldn't have been out at all if it was cold. And then yes, having this big unit out the front collects snow, which again bends the camera, and just another reminder that it would probably be better to put it underneath and have a small camera-only module in the front. Speaking of the camera footage, I watched a very interesting presentation by Dr. Samuel Ramsey, who has discovered that varroa mites feed primarily on the bee's fat body, which is the equivalent of the liver, not hemolymph, which is insect blood, as previously thought. So they tend to cling to the underside of bees, which means that during a hive inspection, when you're looking down on a frame of bees from above, you're not seeing the vast majority of mites that are present. And by the time you are actually seeing varroa mites on top of bees, they've already overwhelmed your hive and are looking to move on. So I tried to work out some way of being able to look at the bees from underneath. I've come up with some options with prisms and mirrors to be able to catch their little bee bellies on camera.
Mm,
which
mm,
would open up AI image analysis to be able to count the Varroa, how many Varroa are in your hive, and just to detect how bad it's getting. So at the moment,
yeah.
the way you do, you just assume you've got Varroa mites and you treat for them, and then you collect a sample of how many your treatment has managed to kill to get an idea of how bad the infection was.
Mm,
And they are pretty much everywhere in the UK. All of the domestic hives seem to have them.
mm. Those mites, some of our listeners may be wondering what we mean. So, do you have any more insight about them, just in terms of the fact that they exist with the bees? Do they exist in other places? Will they follow you into your house?
They feed only on the bees. They are specific to the bees, I think.
Mm,
Certainly only bees and insects like them. They're not native. They were introduced. I'm not sure where from. My wife would be the person to speak to about this. But yeah, they are everywhere now in the UK. They are blamed for the colony collapse disorder, the alarming number of bee colonies that are dying out.
mm,
I'm not sure how strong the correlation is there, but I'm sure they're contributing.
mm,
There are places where they don't exist yet. Australia doesn't have varroa mites, so yeah, we just need to manage them here.
mm, mm. I see. Are there any significant differences between the way that they manage their bees over there?
Well, Australia has very, very strict border controls. They don't allow any food or fruits or vegetables to come in. You can't carry things in yourself, and they've just managed to keep it out completely.
Mm, I see. Okay, cool.
Yeah, and then there's a few more things that I'd like to look at in future. There's being able to run them off solar power or batteries, and maybe expanding on my circuit board design to actually include the circuits rather than to use these little breakout boards that I've been using. It'll give you a lot more control over the circuit design. And yeah, the maybe add a fan as well. The Pi gets very hot if you run high frame rate video streaming on a warm day. So a fan would probably be helpful with that.
Mm. These components, and obviously it's clear that it's taken a good length of time to work through this project, and it's great. It's really great. I think our cadets will enjoy the learning process. I agree with you about the option of buying it already made. Before I got to know of your work, I was aware of another couple who were involved in monitoring equipment, but it seems that they've gone the whole way of making it into a commercial product. And for me, just buying the monitoring equipment is not the point. Although it will obviously give the data, in terms of what our organization is about, cooperative learnership, the process of making the equipment, this is half of the thing, if not more. So just regarding that, if you had to just assemble the bits and pieces, you've got all the raw components that you've used to make your monitoring setup, how long would it take you just to set them up in one go? Not necessarily plugging it all into the hive, but just putting the components together with whatever is necessary to do that so that they work.
I don't know. I haven't tried. If you were to just use these little breakout boards and wire them all together and solder it up, probably a few hours. It's not, the hardware side of things is not very difficult at all. It was the making the data useful that took the vast majority of the time.
Making the data useful. Just expand on that, please.
Yeah, so as I was saying earlier, when it was just being done to a spreadsheet and uploaded at night, it wasn't very useful at all. It was very difficult to see what was happening. You'd have to go and build a chart for yourself if you wanted to see any relationships, and you certainly didn't have real-time access to the data. So yeah, building all the infrastructure to make that available quickly at a glance at your phone was what actually took all the time.
I think maybe it would be useful. You can send me this differently. We can maybe slide it in somewhere, but to show a CSV file with the data, the raw data like that, because obviously some people won't be familiar with that kind of format of information. So it's interesting. Most consumers are used to a graphical user interface, but yeah, the raw data as a comma separated file like this, it would be interesting to see that as well.
Yeah, it's just a wall of text. There's no formatting. There's no spacing. There's no easy way to see what's going on at all. I can send you a page if you'd like to see it.
Well, definitely. I mean, it would be useful for our audience to see that, because even inside of that, it is just a wall of commas and numbers and text and strange stuff. And even if it's anything like our experience with the high altitude balloon outputs, then obviously the system generates its own set of codings and bits and pieces inside of that as well. So sometimes it's not even as just the information that you directly want. There's other things that come with it, which need clarification. But it's important to be able, especially for younger people, to be able to see that something that looks like just a block of nonsense actually contains valuable information, and subject to how you interpret it, decode it, you can get the clarity. And that is exactly what's happening with all graphical user interfaces.
Yes, yeah, exactly.
Okay.
So here we go. End of the day, project successes and problem areas. So the main takeaway from this was peace of mind, being able to just have a quick look at a video stream or a glance at the weights and be assured that everything is as it should be, especially when you're just starting out. This has been our first year of keeping bees, and there's a lot to learn. So it's been really helpful just to have the information available. And yeah, it's been interesting to be able to go and analyze events after the fact. We're not at the point where we're predicting anything yet, but yeah, it's been interesting to go and have a look afterwards. And it's been remarkably stable. This little Raspberry Pi has been running for months without any intervention, and even when the power's gone out, it's started up and carried on as intended. Yeah, and we're ending up with all this data that we can use for future analysis and for training AI.
Regarding the power outage issue, if power goes down and then comes back on, does it just reboot, or do you have to do some rebooting process?
I had anticipated the possibility, and there's scripts that are run when the Raspberry Pi boots up, and I just added it in there, and yeah, it worked exactly as intended.
Perfect.
Yeah, and then of course the wife was happy with the system, which was always a good thing.
Good. A happy beekeeper.
Yes.
Yeah. Happy beekeeper, happy bees. Good stuff.
And then problem areas, room for improvement. We actually covered most of them as we go. It's not a replacement for hive inspections. The technology is not there yet. We're not predicting the future, but that's okay. There's been many gains. The internal sensor position, which I've been talking about repeatedly, is still something I need to solve. I'm actually looking at maybe a wireless option and having the sensor in the roof of the hive, it would get a much better reading there. And if it was wireless, you wouldn't have wires getting in your way all the time, which even with our setup now, with the sensors in the sidewall, the wires have been a problem. In fact, they directly led to the only time I've actually been deliberately stung in anger. We were trying to place our post-harvested frames underneath the main colony, because the bees tend to move their stores up above where their living space is. So if you place your harvested frames underneath, then they go and they clean them for you. They take anything that isn't harvested and they move it up into the colony. But just moving the main colony, lifting the main colony up and placing the honey frames underneath was quite difficult to do with the wires all in the way. And taking them out of the way left the ventilation open for the bees could get out and get in the way.
Mm.
And then I'd like to add maybe a battery backup system. So if the power goes out.
Sorry. So when you say that, so what actually happened then regarding that process disturbed the bees somewhat?
Yes, they just got very, very angry about the whole process. We were knocking the side, pulling the wires out, and
Right.
having to handle the frame nicely because it was stuck in place. So
Okay.
what should have been a quick lift the frame up and put another box underneath for them to clean out became quite a large exercise, and they got quite agitated.
Okay, we'll have to think through that.
Yeah.
In regard to the way we implement this kind of technology, we'll have to think about that quite carefully.
Yeah, and then battery and maybe solar power options. I have a solar panel in the garden I was using to run a greenhouse hydroponics project, so it would be nice if I could power the pie off solar, or maybe have a battery backup, so if the power goes out in future, you don't lose data. So it's just things I'm considering. The GPU overheating when you're streaming, something to consider, and then also the GSM, the communications options, so you can place these further from your home Wi-Fi.
Okay. Yeah, it's cool.
And some benefits. Again, the peace of mind, just being able to see at a glance that everything's okay. Having more tools to monitor the hive health, you're able to get a feel for more aspects than what you can just see with your eyes when you're looking into the hive. And the real-time weight gives really good feedback on the nectar collection rate during summer. I showed you the data. You can really see when there's a good flow on. And then, of course, I've learned loads of things building this thing myself. I've not used the Python programming language before, so I had to learn that to most of the Raspberry Pi code is in Python. Certainly all the sensor tutorials are Python. It's actually a nice, simple language to learn.
What's the difference? On our one we were using the Arduino boards. What would you say is the difference between the coding languages?
So a Raspberry Pi is an entire computer. It's a little computer on a stick. It runs Linux. You can plug a screen and keyboard into it, and it's just like any other computer. The Arduino is a microcontroller. It doesn't have a whole operating system running. The only thing running is the code that you provide it. I think I haven't actually built any Arduino systems. I think they're C or C++ based code, and they probably have to be. Python is a scripting language. Really, it's compiled on the fly, or can be compiled on the fly, whereas the C code is converted into something that the machine can understand and then executed. So it's quite a different system.
Okay.
Yeah, and then 3D printing electronics enclosures and the general electronics and sensor knowledge and building circuits and printed circuit boards. And
It seems to me, or regarding this point, it seems to me you've leaned quite a lot on the fact that you've got a 3D printer. If you didn't have a 3D printer, can you imagine, would that be much more complex in terms of?
No, it would probably have been much simpler if I didn't have a 3D printer. I think it looks a lot neater when it's got a customized little enclosure. But I've seen clear plastic food containers used very effectively as electronics enclosures. They're waterproof and they're transparent if you need a camera, and you get those Tupperware ones or the little click block ones, you can snap them down.
Mm-hmm.
So yeah, it would probably be a lot quicker and easier. It just wouldn't look as neat, that's all.
Okay.
And then some of the other insect projects that my wife's involved in, black soldier fly. I've set up similar monitoring systems for those as well.
Do you keep black soldier flies in your house, in your space?
We actually were keeping them in the shed, but in winter it really got a bit cold. So we do have a small colony of black soldier fly in the house, in our conservatory, enjoying the sunshine.
What's the purpose of that? I mean, obviously it's interesting, but obviously the beekeeping, everyone knows it's honey. There's honey involved as a little reward for that. Tell us a bit more about the soldier flies.
Yeah, they're amazing little creatures. They're the fastest converter of biomass to usable protein on the planet. They can get through food waste at an amazing rate. They process all our kitchen waste, and
wow.
they are very rich in protein and fats and calcium. They're really good for animals to eat. So they're often a protein substitute in things like dog and cat food, and they've been approved now for feeding to fish in the UK, and in the process of being approved for commercial use for chickens. And if you keep small reptiles like chameleons or bearded dragons, they're great for that, or spiders even. We know someone who's got a tarantula that likes to eat these. And they're very useful. I'm not sure about people eating them yet. The UK is probably not prepared to consider eating maggots yet, but maybe crickets or mealworms.
Fascinating. I at one point I was a keeper of the Philocrania paradoxa, the African deadleaf mantis. So in the process of doing that, I kept some other things like the crickets, but I can see what you mean. Fascinating. That whole bio waste is a whole nother conversation. Very, very interesting. The science of bio waste with bio waste management with creatures like this. Okay.
Yeah, the frass that they leave after consuming the food is really good fertilizer. So there's no waste. It's a very economical system.
So you have some kind of containment unit that you put your waste. They do what they do with the waste, and then just churn out compost for you. Is that the idea?
Yeah. We're just using cheap IKEA storage drawers, plastic drawers. They're quite happy in there. The hard part is actually getting the flies to mate and produce eggs, because they're a tropical species. They're not native to the UK, and they need bright sunshine for a lot of hours in the day and very warm temperatures, which is why they've ended up in our conservatory at the moment. Hopefully they can go back out to the shed soon.
So is there any, obviously you've got them contained in some sort of way, right? So if they come out of the containment, what does that mean in terms of the environment? Will they just die because the climate's not good enough?
If they were outdoors, quite possibly, certainly in winter. don't really get out of the containers unless it's too humid. If it's very moist, then they can climb up the walls and climb out. But if you keep the moisture levels down just to what they need, then they tend not to climb out, and they just stay in the trays. They self-harvest, which is nice. They have a climbing instinct when they're ready to pupate. So if you do put a ramp in your tray, then when they're ready to pupate, they just climb out. So you can just hang a bucket underneath, and they harvest themselves.
Fascinating. Okay, cool. Thank you very much. That's a little bonus insight there on the soldier fly. Okay.
Webinar, being 9, more detail mastery. On our level being webinar, 9 mastery program. Level being 9 mastery program. Wow! Mastery program. Level being 9 mastery.
So, yeah, let me leave you with an interesting event that we captured. I'll just run through it first, because I won't be able to speak over the video, I don't think. So when one of our hives was preparing to swarm, we split the hive. So we took the queen out and some frames with brood and food and stores, and replaced them into a small temporary colony called a nucleus colony, or a nuke. You'll see the word nuke appearing a few times on this chart. So the graph is just grabbed from Grafana. And we placed the nuke next to the original hive, which was probably a mistake. And we blocked the entrance of the nuke with a queen excluder, which is a grid mesh that is big enough to let the workers come and go, but it is too small for the queen to leave, so it keeps her contained. But in the process, we also trapped a lot of drones in the nuke, the drones of the male bees, and they don't contribute to the colony at all, other than mating with the queen on her mating flight at the beginning of her life. So they just consume the limited resources that were given to this new colony. So we opened the nuke to let the drones out, and the queen fell out. I say fell because the queen's wings are clipped to help prevent swarming, especially in the dense urban area like London. So yeah, she wasn't able to return to her hive or the new nucleus colony. She simply fell out. And this interesting...
Sorry, just to say that this point is very interesting, because in a previous podcast, which we did with beekeeper Katie Langley, we discussed this, and beekeeper Abena. We had a conversation about the clipping of the wings and the fact that the bee basically can fall out, and when they swarm, they not to preempt what you're saying, but when they swarm, the queen thinks that she can fly, and she will just try and then just fall, and the rest will just go. and there's a bit of a thing that happens. So it's interesting that you're now talking it through in your live example of what's happened with you and your setup. But yeah, please do continue.
That's exactly what's happened. But what's interesting is that the hive that swarmed was not the hive that the queen fell out of. She was sitting in the nuke next to the hive. So it's interesting that the hive that didn't actually have the queen got the signal to swarm when she fell out. I don't know if that's an audio signal or a pheromone signal or how they knew, but yeah, it was very interesting that the hive that she wasn't even in started swarming.
So
yeah,
do you think that she released some kind of distress signal or some kind of some sort of signal? Let me not say distress, but obviously it must be distressing to try and fly, realize your wings are clipped and then fall to the ground. That I would guess is a little bit distressing.
I don't know about a distress call, but as we were talking earlier about the audio AI, the audio AI was able to detect about 20 minutes before a swarm that a swarm was coming. So there's quite possibly an audible signal that the hive is preparing to swarm.
What I'm trying to get to is there a link between the queen being out of the nuke and the beginning of that sound when they were preparing to swarm?
Normally the beginning of the sound would be before the queen leaves, because I think the queen leaving is what triggers the swarm. So
okay,
but I'm not sure what the mechanism is for that, whether she announces to the hive that she's wanting to swarm, or whether the bees kick the queen out because they want a new queen or something like that. But yeah, it's just really interesting that it worked not only within the specific colony that the queen fell out of, but in the neighboring colony that was her former hive. So
okay.
yeah,
so obviously, just in regard to what you're saying now, because that's a whole nother point. We did another podcast on the genome of the bee, and so obviously the worker bees in the other hive, they're all genetically related to that queen that fell out, isn't it?
Yes, and in fact, she'd only been out for a few days, so they probably
that's their queen, that's their lady, that's their one. Yeah. Okay.
Yes.
Okay.
It did take us a minute to work out what had happened. We walked out into the garden, and there were bees everywhere. They spread out over several properties, probably annoying loads of neighbors. But once we worked out what's happened, we found the queen on the lawn and put her back in the nuke, and immediately all the bees started returning again.
So just out of interest, when you say probably annoyed the neighbors, did that not generate some kind of conversation?
No, nobody said anything, but I did see a few slammed windows when I was outside.
Wow. Okay. Well,
yeah, it was quite spectacular to see. There's actually a little bit of footage I've got a video we can have a look at. There's a little bit of footage of all the bees flying around.
Okay.
In fact, yeah, let's have a look at the video now. I mentioned this was quite early on, so I have the time-lapse footage of this, and I've post-processed this, so this wasn't real time. I've added an audio analysis underneath, and because it's a time-lapse, the audio is 1 minute recorded every 5, so it lines up every minute of real time.
Fantastic. What an amazing experience. I have a question about this, a few questions, but when you say you put the queen back in, you put the queen back into the nuke or back into the original hive that she came out of before?
Back into the nuke.
Right. So if I can just be clear what we're saying here. So you've got two hives next to each other. One is a lighter one because you're basically starting a new one, and the queen has fallen out of the new one. The hive, the old one, the original one that she was in before, starts to swarm. You put the queen back into the nuke, the new one, and the bees start to return back into the old one.
That's right.
Right. Okay. Do you have any sense of reasoning about why they would return when the queen has been put into another box?
Well, there's definitely some signaling happening that the swarm is happening and that the swarm is over, but what that mechanism might be, I don't know. The whole thing only took 20 odd minutes, I think, if you have a look at the chart. So they left really quickly, and yes, as soon as the queen was back, they started returning.
Fascinating. Okay, well, that's absolutely amazing. Yeah, thanks for that. That's good stuff.
Yeah, a pleasure. Thank you for inviting me to speak.
Just another point about the video. Obviously, I had a preview of that video, and I tried to slow it down to see if what it would be like in slow motion. You were saying that the resolution, you had to take a certain resolution to get that to work. It would be obviously great to see bees in slow motion in detail. What sort of resolution or capacity do you think you'd need to have in the equipment to see the bees in slow motion in a quality resolution?
Well, the Raspberry Pi is capable of recording video at about 30 frames a second. So you could slow that down, and it would be a bit jumpy, but you would have a slightly slow motion, but it's not going to be amazing. You really need better technology than this to produce really high quality slow motion videos. But
Okay.
yeah, this video that I produced was quite early on. It's quite low resolution, and it's quite a low frame rate. So the video now is live HD video like you'd get from a webcam. So it's considerably better than it was in the beginning of the project. But yeah, it doesn't get a lot better with this kind of hardware.
Okay, well, it was very illustrative of a dynamic, and yeah, fantastic. Yeah. Okay, so you've completed your presentation, Richard. Is that right?
I have reached the end.
Wow, fantastic. Thank you so much. That was amazing. An amazing journey into the tech and the power of applying it. It was a good way to show it at the end, having talked about all of the principles of how you came about setting these things up, to see that dynamic of the footage and the data. Yeah, really, really good. So I look forward to hearing more of your developments. I'm sure you must realize by now that I'm hoping you're going to help us in some way with our setup as we take steps into this development of monitoring. But we can have different conversations about that. And what do you intend regarding this project? Where do you want it to go?
Well, it's ongoing. I'm still improving. I've got a new version on the go at the moment, and I might make it available, or at least the software, the hard parts, available for people to use. But I think that's some way off still, and I'm not getting that much time to work on this, at least during lockdown with small children at home all the time.
Mm-hmm.
But schools are going back soon, so maybe things will pick up.
Okay. Okay, cool. Well, Richard, thank you so much for that. It's been a real pleasure to speak with you. And yeah, I look forward to hearing more of your developments. And I will very happily share with you more insights from our members, from the community, and all interested ones. We'll make sure there's a way to keep this conversation, insights that may come from other quarters about what you said, and we'll make sure you get the engagement of that, the feed forward on that one. And yeah, great. Thank you very much.
Yeah, you're welcome. Keep in touch.
We will.
Webinar 9. More detail mastery. On our level being webinar 9. Mastery program. Detail on level 9. Mastery program. Wow. Mastery program. Level being 9. Mastery.